This resource is the third in a four-part series on graphing trigonometric functions. Part 1 looks at the graphs for the two fundamental trigonometric functions, sine and cosine. Part 2 considers the various features of the sine and cosine graphs. These features are defined, and methods for finding each are presented with an example. Part 3 suggests using the features of the general sine or cosine as stepping stones for graphing a general trigonometric function. Part 4 looks at the graphs of the other four trigonometric functions, formed from ratios involving sine and/or cosine. In the previous installment of this series, we discovered how to find the values for the important features of a sine or cosine graph. Now we will use those features to create a process for graphing a general sine or cosine function. First, find the amplitude. Since this is the maximum value for the function, it gives us an idea how to label the y-axis on our graph. Next, we find the phase shift. The phase shift lets us know where our graph needs to start. Find the period. Now we know how far in the x direction we need to travel before our graph completes its full cycle. Divide the period by 4, which suggests how we will label the x-axis. Find 5 critical x values. We will discuss exactly what this means soon. Find the y values for those critical x values. These values depend on which function we are graphing, but follows nice patterns, as we will see shortly. Plot the 5 points for which we have discovered the coordinates. Connect the points to complete our graph. Do not merely connect the points with straight lines. Because we are graphing trigonometric functions, remember to make the graphs curvy. Finding the x values used to graph our function takes a little work. X sub 1, the first x value we consider, is our starting point. This x is the value of the phase shift. Dividing the period by 4 tells us what we will be counting our x values by. X sub 2, our second x value, is the first value with this period divided by 4 quantity added to it. In other words, x sub 2 is the phase shift plus the period divided by 4. X sub 3 is the second x value plus the period divided by 4. X sub 4 is the third x value plus the period divided by 4. There are actually two different methods to find x sub 5, our final critical x value. We can either maintain the pattern we have used to find the other x values and add the period divided by 4 to x sub 4, or we can add the full period to the very first critical x value. I recommend using the second method. Now that we have our x values, we need to find the appropriate function values for those points. We could insert the x value into the function and perform the appropriate calculations, but this invites errors. A simpler method is to use the charts of values on the screen right now. Just make sure you use the right chart, depending on whether you have a sine or a cosine function. Let's work through an example to see this method in action. Suppose we want to graph the function y equals 3 times the sine of the quantity 2x minus pi. First, we find the amplitude of the function. This is the absolute value of 3, which is 3. Now we find the phase shift. Because we have a minus pi, our phase shift is actually positive pi, divided by the 2 that is in front of the x. So our phase shift is pi divided by 2 to the right. The period is 2 pi divided by the 2 that is the coefficient of the x. When simplified, our period is pi. To find the increment for our critical x values, we divide the period by 4. Our x values will be incremented by pi divided by 4. Now we will find our critical x values. The first is simply the phase shift, or pi over 2. The next x value is our first plus the increment value. We have pi over 2 plus pi over 4, which simplifies to 3 pi fourths. We add pi divided by 4 to our previous x value, which simplifies to pi. Repeat the process, and we wind up with 5 pi divided by 4. Our final x value is the phase shift plus the full period, or pi over 2 plus pi, which equals 3 pi divided by 2. Now that we have all the x values, let's find the corresponding y values. We are graphing a sine function. This means the y values for x sub 1, x sub 3, and x sub 5 are all 0. The y value for x sub 2 is 3, because that is the value of a from the function. The y value for x sub 4 is negative 3, which is the opposite of the a value. So we have the points pi over 2, 0, 3 pi over 4, 3, pi, 0, 5 pi over 4, negative 3, and 3 pi over 2, 0. We plot those points. Connect the points, and we have graphed our sine function. But what happens with the other trigonometric functions? What do the graphs of tangent, cotangent, secant, and cosecant look like? Stay tuned for part 4 of the series.